Thank you all for joining us today for the Markforged webinar, Onward and Upward, Strong Parts, Takeoff with help from CFR and Blacksmith at Hangar One Avionics. In today's webinar, you will learn about the impact of additive manufacturing, the critical role that continuous fiber replacement plays, the advantages of digital quality inspection for 3D printed parts, and how to work with the FAA when making parts that will go on aircraft. We're fortunate today to have three members of the Markforged team, as well as a special guest, Matthew Roth of Hangar One Avionics, one of our customers. Let's do some quick introductions. Charles?
Hey everyone, I'm Charles Liu, Product Marketing Manager at Markforged. Formerly, you might have known me as Charles Liu Application Engineer. I still go by that sometimes. Once an application engineer, maybe always an application engineer. So I'm going to talk a little bit about CFR and help answer any technical questions. Mark?
Great. My name is Mark Levitt. I'm Product Marketing Manager for Software and Security here at Markforged. And I'm excited to be, I think, on my third webinar for Markforged. Chloe?
Good morning. I'm Chloe McGuffin. I'm a strategic application engineer at Markforged for our aerospace customers. I'm going to be talking about the things we're doing to support our aerospace customers and the things we're doing to support certification of some printed parts and answer any questions around those topics.
Super. And Matthew?
Yeah, I'm Matthew Roth. I'm Engineering Manufacturing Manager at Hangar One Avionics, and we're going to talk about a little bit about how we're integrating 3D printing and inspection into making parts that we're flying.
Great to have you here.
For everyone here who's, hopefully you've had some exposure to Markforged, I'm just going to go over quickly the basis for continuous fiber reinforcement and kind of describe the process a little bit before we get into the really meaty topic of how we apply this into parts that fly. So Markforged's proprietary additive manufacturing process is continuous fiber reinforcement. This is really why we exist today. What that means is we're adding a continuous strand of fiber material into a part, and we're laying that almost as if it were another bead of material, but what it's doing is it's adding like incredible strength to the part, an order of magnitude strength where it exists. That allows you to get metal strength properties at a fraction of the weight, putting carbon fiber or Kevlar or fiberglass where you need it most. This process allows you to choose different fibers, put them in different places, and as we advance our software even further, you'll be able to have even more finer control of that. So why is that important? Well, the power of CFR comes from where these strands are continuous through the part, and our process is really great at distributing loads through the entire length of the part, and you might actually be able to see that in some of the examples today. As an overview, there is a pretty big distinction between short fiber filled filaments like Onyx and continuous fibers, CFR. So we're really one of the only players in the market that makes continuous fiber reinforcement where you get this order of magnitude strength increase. Most of the other claimed carbon fiber 3D printers are using the short fiber filled filament, which is like our base material Onyx. This is really good for improving dimensional stability, for improving print quality, improving surface finish, but it's not going to give you that strength, and especially not that strength to weight ratio that you would expect from a carbon fiber material. To give you an example of this is our base level fiberglass reinforcement with Onyx. And compared to Onyx, ABS, and PLA, this is really kind of a pretty distinct difference. Whereas the fiberglass reinforced Onyx is able to resist that bending load, and Onyx is a tough material which bends and does not break, you'll see that the ABS and PLA materials are actually not even able to hold up to this type of load. Next slide, please. And when you take that and you apply the continuous carbon fiber in a way that is optimized for print performance, you'll actually see that it might be stiffer in some instances than aluminum. For just a brief comparison here, these are tensile strengths, and obviously the aluminum one here isn't necessarily going to need to be conditioned to ASTM D638, but you can see on the left aluminum 6061T6, and going to the right, you'll see some of those chopped fiber composites, and we're going to see somewhere in the order of under 100 megapascals in tensile strength. So some of these fibers will claim to be, on the order of 100, but really they'll be closer to 60 because they've conditioned differently. Onyx, we're going to say, is at 40 as conditioned. ESD is at 60. But as soon as you start to add a little bit of fiber, whether that's 20% or 40%, even 10%, depending on the size of your part, you're going to start to see this like multiplier effect of strength. You can add a single ring, a concentric ring of fiber, and add that like a really high amount of strength. And somewhere between 20 and 40%, you're going to be able to match the tensile strength of aluminum. So, and it just kind of goes from there.
Great, thank you, Charles.
To you.
So we spent a lot of time in the past 2 years talking about supply chain. Some of that supply chain is within your organization, getting tools and tooling, to various parts of your organization, as well as getting parts to your customers. And one of the things that we've been working on is being able to help validate part quality at the point of fabrication, so you can de-risk that supply chain. And our focus is really the in-process quality control, different from kind of more of a manual visual or caliper check or separate inspection processes. Companies tend to handle part validation in a myriad of ways. Sometimes they don't do anything and they take the risk of parts failing or not fitting. Other times they'll often use a validation process that requires a unique setup for each part, and then an inspection that happens after the part is produced before it can be used. Some parts require only a quick check with a manual gauge, but even manual gauges need to be calibrated frequently and can generate results that may not be repeatable from one caliber to the next. Other parts require a resource-intensive coordinate measuring machine, or CMM, which also involves typically time and therefore delays before the part can be used. For manufacturers with multiple locations, there's often a lack of consistency in the part inspection and validation process. The result is that the same customer, if it's a customer and used part, may have very different experiences with parts coming from the exact same manufacturer. Markforged is changing this paradigm with point of fabrication inspection, with a built-in and touch-free tool chain for delivering high confidence QC reports. Markforged printers that are equipped with Blacksmith ensure the customer gets the right part every time, with less time and expertise required. We refer to our Blacksmith software, which runs as part of the Eiger cloud-based software for slicing and printing, as the autopilot for digital manufacturing processes. It connects part design, production, and inspection with powerful AI. With Blacksmith, customers like Hangar One Avionics, as you'll hear and see soon with a demo of Blacksmith, can create automated part quality inspection that efficiently and reliably certifies the accuracy of parts so they can be used immediately after printing. Blacksmith helps save time and money and increase the reliability by replacing manual inspection processes using hand tools, expensive scanning equipment, or third-party inspections. Now, without any further delay, it's time to hear from our guest speaker, Matthew Roth, about his experiences with 3D printing of parts for his aerospace customers.
Good morning. All right, so a quick little background on what it is that we do here at Hangar One. We specialize in avionics and completions for the law enforcement, special mission, helicopters, and fixed wing. We've been in business about 15 years, and majority of our customers, it's all different types of government contract work. And what we've come to realize is that our customers, everybody wants something different. So it's very interesting for us to be able to provide one customer one day with one thing, another customer next day with something else. There's very little actual repetitive production work. because of that, we've been able to build ourselves a, fabulous fabrication and machine shop here that we can use to build all of our custom one-off parts for our customers. A few years ago, I had a gentleman who worked for me, and we were sitting here talking about 3D printing. We were talking about making stuff just for our, our house, little desktop printer, and we bought one, and we had one sitting around here. We were making little parts, for little R&D parts. We really quickly realized we need something better. We had talked, another one of our guys who works here had a previous employer had used one of the Markforged printers and with the desktop models, and so we invested in that. Bought one of those, and just to make R&D parts. I would say within about 48 hours of us having this up and running, we were starting to make tooling and other things that we hadn't even thought of yet. We've realized in the aviation industry, as probably a lot of people know, a lot of the tooling that is for certain products aren't available anymore. Companies are either out of business, or the timeline to get one, or maybe there's only one tool that is, somewhere in Europe or wherever it may be, and trying to get that is going to be it's going to cost too much, or it's just not available. So we've been able to, we started reverse engineering some of these toolings for some servos and making some sockets, because the information was out there. We were able to reverse engineer it. We 3D printed it, and we put it to work. And we realized really, really quick that, using Onyx and, having the carbon fiber reinforcement in this really was going to start paying off. Really quickly, we kind of started thinking like, well, how can we take these parts that we're printing, and what can we actually make and actually apply it to parts that we want to fly? That's where talking with Markforged and investing with an X7 and Blacksmith, we were able to realize that we can do, there's a lot of parts that we make that are non-structural parts that we can make, and we can certify them, and we can test them, and we can actually put them on aircraft, and we can fly these parts. And this is where Blacksmith came in, because as everybody who's in aviation knows, it's, you have to be able to document everything. You have to test everything that we do. And working with Markforged, we were able to come up with a plan and come up with processes and put in place to be able to move forward with all of this.
Matthew, what was the very first part that you 3D printed and put on an aircraft?
Very first part that we 3D printed and put on, oh, actually, you know what? It was a cup holder. That was the first thing. One thing that we've realized from like a lot of our law enforcement customers, is because it's in helicopters, is there's a way to hold their water, which seems like such a simple thing, because you say, okay, you have a water bottle, where do I put it? And the problem that people run into is if you just stick it on the floor, you don't have it secured. If one of our guys, if they were to go into an orbit, that water bottle can end up down in controls, down at their feet. It was always a bad deal. So years ago, we actually started making these cup holders. And these are aluminum with just a carbon fiber tube that we made. And we actually still make quite a bit of these, and they work great. Problem then comes up is that it doesn't work for every aircraft. And so what we ended up doing was saying, okay, well, how do we apply that, or how do we make it work for a different aircraft? And so we, as you can see here, so here's another cup holder, large taper because of where it mounts in the aircraft. And we were able to take this and print this instead of having to try to machine it. And I believe this is one of the first actual flying pieces that we had. And when we did this, we looked at the amount of time it would take to machine this versus the time it would take to just print it. And it was significantly less setup times. We could just hit print, go, and we had a done part. And then from there, we would take this and we go into post-processing, and we use aircraft primers, aircraft paints in order to paint it. And you end up with a nice, shiny part that is totally finished. And this part is actually we have multiple of these that are flying right now for a certain airframe. One of the things that we came across with our customers when we started talking to our customers about 3D printing was everybody was like, well, it's plastic, it's not strong enough. And I can sit there and I can tell a customer and I can give them numbers about, how much it can actually hold, but that doesn't mean anything to most of our customer base. One thing that we do, and this is, as you can see, this one is quite beat up now. This is the one that we keep on our shelf sitting in our shop here. And we've had guys who are about 250 pounds in full flight gear and equipment come in here, take this and jump on this thing, and they can't break it. And once they physically see and they do something like that in order to, try to break it and they can't do it, then they're like, oh, okay, that works. We're okay with that. Because that's their way they quantify whether or not it'll be work. They try to break it for us.
In the past, when you've made machine parts, what was the inspection process, and how did that inspection process change when you moved to 3D printed parts?
Our inspection process has always been, we create a set of drawings, and then we would do manual inspection using hand measuring tools and grant tables, things like that. Which, for a lot of our metal parts, at least, we obviously still do that now, or we'll use a laser scanner to laser scan to check the parts for dimensional accuracy. One of the things with the blacksmith is we don't have to do it. It's all done in the machine. And not only is it done in the machine, I can save those type of settings and my inspections into blacksmith, and then that way I can utilize it in the future. We record everything, just like everything with the FAA. We record everything, we document everything from start to finish. The batch of materials, the certificates, and then with the our inspection reports, and all of that gets taken, and we put that all together and have a nice little package that we'll put on our server. And or if it's that paper has to go to the customer, we'll give it to the customer as well.
Can you show us what that looks like in blacksmith?
Sure can. Let me. All right. So this part here, and which we physically have one of here, this is just an adapter plate we're using for mounting a modem for a customer. And so here we have our inspection. So we want to take a measurement, say, between this bore here and this bore here. And we know the distance between here is 112.49 millimeters. This is just because we don't work in metric in our shop, but so I know what it's supposed to be. It's supposed to be 4.428. It comes in at 4.429, and I am way within the tolerance range that I need to have for that dimension right there. We can do the same thing on these two bores here on number 2. We know that it's supposed to be 50.1, coming at 50.13. There we go. So 50.13 millimeters, it's supposed to be 1.974. We are dead on at 1.974. This is the thing that's actually really crazy about it. With certain parts that we have repeated, the repeatability on this is fantastic. It's exact same as what we'd have on one of our high-end 5-axis machines. It's always good. It's always repeatable. Let's see. So then we can come down here and we can say, okay, we've got this section in here that we're going to take. And we're getting, where are we at here? 9.68. All right. Again, we are within our tolerance here. And number 5.
We've got a question in the chat
sure.
here. That's about how is this inspection performed? Is it CMM? Is it a 3D scanner? I'd love to hear from you, Matt.
Okay.
How is this happening?
So as the part is being printed, when we first program the part, we tell it, what type of accuracy we want to have for this. What's happening is that as it's being printed, there's a little laser inside the machine that is laser scanning the part as it's printing, and it's picking up data points. So if you look on here, you can see all these little dots that are over here. These are all the different data points that are being generated by the actual print while it's being printed. And then it's taking all that information and it's giving us all of our dimensional data based off of that. And one of the things that when we first were using this, we were, to say the least, a little bit skeptical. So the first, I would say, dozen or so parts that we did, no matter what we did on here, we would still go back and check them manually, calipers on the tables, using other CMM to do it. We even went to the point in time of, printing, a cube that's 1 by 1 or 2 by 2, and then taking that and checking the dimensioning on that. And we've realized that it is so far within the specs that we keep here that we're so not even worried about it anymore. When we've gone through and worked with some SDC packages, working with ODAs and DERs on this, one of the things that the question we get asked about it is, well, how do you guarantee that it's doing what it's supposed to do? And I think, actually, let me just tell this story. We were working with someone working on an SDC package. The ODA and the DER were asking about the inspection process. And so I started telling them in an email, I was like, we're using Blacksmith and we're doing all the measuring and all this. And I get an email back and they go, so you guys are like, have a forge in your shop? What is this Blacksmith? And we actually, we got on a Zoom meeting. I shared the screen with him and I started showing them the ODA and the DER this. And I said, look, here's what it's doing. It is scanning all this part as we make it. We can take it and using that scan data, we can check all the stuff. And one of the guys asked me, he goes, well, how do you know it's really, what it is? And while we were on the Zoom meeting, I showed him, I was like, look, here's what it's telling me on here. Here's what I'm measuring right in front of you as you're looking at this. I said, the accuracy this has is actually a little bit better than what we're measuring currently. I said, we've gone through, we've checked this. Is there what else do you want to see from us? How can we explain this to you better? And the guy kind of looks at it and he's like, well, show me something else. I show him another part, same thing. I had a little like 1 by 1 cube. And once they understood what it was that we were doing and how this works, all of our ODAs, DERs, and actually, the people we deal with the FAA, we're all like, oh, there's no difference between this and using, if you were using a laser scanner CMM or a probe style CMM, it does the exact same thing. It's just, this is new. So they don't know about it yet. They don't understand it yet. And once you talk to them about it, then everybody's been really, really open and really accepting of what it is that we're doing here. Especially when it's, we're able to document everything, which is a big thing, is always document things. So the other thing that's nice about this is the saved measurements. We use this all the time where I can say that I need a measurement between these two bores that are here and it'll generate that number for me. And this is how we, we'll run it, is like this. And so we can say, so for number 7 is 149.95. What was it here? And 6 was. And so
that's is that persisting? So each time you print it, it's giving you a new set of measurements, and
correct.
It's remembering that measurement that you took the last time.
Correct. And then what we do with this is every single part that we have, well, every part that needs to be inspected, we will generate the inspection report at the end. Right. And the inspection report down here gives me the measurements. So for measurement 1, here is what the nominal value is. Here is what was measured. Here's what your deviation was, and it'll give me all of this. And this whole report that we have, this goes along with our inspection reports. It goes along with our set of prints. We package it up all nicely, and it either gets scanned in and goes on gets attached to the part digitally in our system, or if need be, we will print it all out and we will give it to a customer if we're printing something for a customer part.
It sounds like you've gone from a manual process to a digital process. What's kind of the benefit of it being a digital process from end to end?
Well, a couple things. A, my handwriting sucks, so I can actually read what I'm saying now, which is always nice because the only thing I have to do is sign a piece of paper. Honestly, it's the speed of it. The speed of having to do it versus doing it digitally versus having to go over and pull out all the measuring tools and getting that all set up has been greatly increased. Having it all in one place is really kind of the nice part. If you're looking like our inspection receipt that we have here, we record what the print date was and the time of the print. So we can always go back and say, okay, maybe we had a problem with this, or maybe we didn't. We could always go back and look at it again, and we have all this information readily available for us because we can just if we had multiple prints, you'd have multiple prints showing up in this drop down here. So we can always go back and find that real-time data of what it was. Another thing that I actually really like, and with working with you guys at Markforged for quite a long time now, is the constant updates that you guys have been doing with Blacksmith. And I can go, if you guys have done a major update as far as the accuracy goes, I can go back and rescan a part, or excuse me, recheck that part based on the new data that you guys have put into the system, which has been really nice. And it's given me more features, things like that I can use now. So we've been really, really happy with it. Just streamlining all of our processes with this.
And Matt, I don't know if you've ever had this situation, Matt, but have you ever had a situation where you've gone through and done your quality inspection and discovered later you needed another dimension, and gone back and taken more dimensions out of Blacksmith?
100%. That has totally happened to us. I was doing a part, and the DER came back and he's like, well, I really need you to measure this. And so we just went back, put it in the system, remeasured it, sent him the data, 20 minutes later. So that's super helpful, because that's the whole thing too, is that if I have that part and that part is gone, already installed, and DER, ODA, whoever may be, says that they want something, well, you're kind of SOL. Well, I don't have that problem anymore. I have all the information here.
I know that you use fiber for nearly all of your parts to reinforce them, to make them strong and lightweight. Have you taken advantage of the newer feature that kind of validates that fiber has been placed in the part in the areas of the part that you had designed?
Yeah, once that became available, we enabled that right away. For us, even there's parts that we make that basically any part that we do that goes on the X7 is going to get run through Blacksmith. Even if it's an R&D part, because what happens sometimes is, well, we have a part, we're like, okay, we're going to make this for R&D, and then we get done with them, we're like, you know what, this actually worked perfect. And then that way I don't have to make another part with Blacksmith enabled. It's already done with. Especially because the majority of our parts that we make here, it's not something that's being printed in 20 minutes. It's something that's, going to be, 10, 12 days long. So what's the, when it does the Blacksmith, it does take a little bit longer because of the laser scan, but realistically, it's not long enough to make a big difference for anything that we're doing. We just schedule accordingly for it.
When you say you run through Blacksmith, what is the difference between a Blacksmith scan part versus a non-Blacksmith scan part? How does that affect the way you print?
If you have Blacksmith enabled, then it's doing all the laser scanning and collecting all the data while it prints, versus we can just say, if you want to say, like, I just want to print this little part really quick, just to test it real quick, you can leave it disabled. It won't do any of the laser scanning or anything like that as it prints. But anything that's possible that could fly or end up in a customer's hands, we'll just enable it anyways, because the time difference for us isn't that great.
Yeah. Hey, Matt, there's a question in the chat. Maybe you can tell us a little bit about what you do to calibrate your printer and what you do to make sure your printer stays in calibration.
Good question. So the X7 comes with a calibration plate. I usually run it overnight. I think it's about a 4 or 5 hour process, I believe. And that calibration plate is linked to calibration data that is in the cloud. It will run scans over this plate to be able to calibrate the laser so it knows where it is. We have that set up on a cal schedule, just like we do everything else here. The machine is on a certain point in time during the year. So we do that. The other thing too is all the automated features as far as like the maintenance stuff goes, whether it's replacing nozzles, tubes, things like that. We stay on top of that. The big thing that we find is it's just a visual inspection. This happened a couple of days ago. We had a couple parts that were on there. We were pulling them off, and we noticed that the fiber was starting to come outside the wall a little bit. And we're like, okay, well, something happened. Maybe either someone bumped the machine, which is totally possible in our shop, or something happened and we just had to recalibrate where the fiber nozzle was. And so a lot of it is just like, if you know the machine and you've been using it a little bit of time and starting to see when you start noticing differences in the print, or if Blacksmith starts kicking back apart saying, hey, you've got a problem here, then you investigate it just like we would anything else. Our 5-axis for machine, for example, I mean, if the earth decides to settle a little bit, from 1 week to the next, we have to go back and reset it a little bit. Just those visual inspections and using Blacksmith has been able to kind of alleviate a lot of that for us. And then it's just staying on top of inspections for us too.
There's a question. The part that you show is a relatively flat part. Can you describe any more complex parts that you've been able to produce and analyze and inspect with Blacksmith?
Yeah. Can you guys see me, or should I close the screen here? Okay, more complex parts. This is a very large cup holder that we made for a customer. I would say 3-day build on this was about the build time on it. And this whole thing was done in Blacksmith. What's the way to explain this? Utilizing it, especially with something that's this big, and especially something that we know that's going to be flying, has been, there's parts on here where it's, how would you measure the inside of a bore that's down inside of that? That's, super hard to do, especially with how the geometry of this is, where we don't have to worry about that. We can have it in Blacksmith and we can measure it, and it comes out great. What else get around here? Same thing with, something like, this was a tool that we made a few weeks ago. Same type of thing. We can take this, we have it in Blacksmith, we can measure all the different spines that are on here. We can measure all the bore sizes that are on it, and we can verify before it was being used.
You talked about some, Blacksmith shows you kind of the deviations from the original spec. Can you talk about what the significance is? Do you ever say it's outside of our tolerance? I mean, or does that happen? I mean, how do you deal with the information that you see in Blacksmith?
We have had stuff go out of tolerance. One thing that so this actual part, which was the part that was on the screen, when the first one of these we printed over the weekend, I did not put enough glue down on the platter. And so the actual corner of this had come up, and it was interesting in Blacksmith to see the fact that it was all, kind of out of whack in there, and it caught it. A good cleaning of our platter and new glue, pretty fine afterwards. But it shows things like that. We've had it where, let's see what else. We had warping one time because our air conditioning gave out in our shop, and it got 100 and something inside of our office here over the weekend, and we started noticing warping in the parts. Blacksmith caught that, and we were able to say, oh, hey, there's a problem here, and which we, by looking at the part, we could easily see as well. And then sometimes it's design things. Sometimes, we're designing everything in SolidWorks, and sometimes you miss a decimal point somewhere, or just trying to get through something real quick and not paying attention, and you output it and kick it out as an STL, and you think everything's right, and then you come back later and you go, wait, I missed something, and you tracing back and realize that it wasn't even a Blacksmith or printing issue. It was something that you had back when you were doing, making the models themselves.
There's a question about how much time does the scanning add to the printing process? Do you have I know that on Blacksmith, actually even before Blacksmith, you can see before you print the part how much time it estimates it'll be, but what's your general experience with scanning time?
It's about 10%. Yeah, I'd say about increase about 10% is probably about right. Again, with most of the stuff that we print, we have everything scheduled out pretty well, and we know, if it's something, something like this is going to be, 18 hours. Well, what's an extra 10% on top of that? Not much, especially because we're not here 24/7. So, you start at the right time, and you know when it's going to end, and we schedule it based on that.
Yeah, Matt, you probably didn't see the first rendition of the in-process laser scanning on the X7, it used to scan every single line. Like it would scan the entirety of the build. It would give you like the infill. It would give you, 10 microns at a time, right? And that process used to add hours to a part. And I think what we have now is a really elegant way of scanning the part where we're kind of saying, based on the resolution that you specify, we're selectively taking points and edges along that part and saying this is what it is. If you want to verify fiber, it's scanning the fiber. It's not scanning the whole thing. And yeah, I think that's really kind of a demonstration of the power of software where, you're saying that with some of the features, like adding features later, it's like if you can get a good point cloud, there's so much more that you can do in the software to like add value over time.
Absolutely. And I think that's one of the things, as far as what we've been concerned, we've been really happy with working with you guys is, given, obviously us and other customers giving you the feedback of like, hey, what is it that we're looking for? Yeah, we don't need to scan every layer. Maybe there's some reason we do need to scan every layer for some reason, being able to have those options and have it available and having you guys listen to us and be like, this is what we really need. Here's how we're really using this has been wonderful, because especially for us as a company, we're not a production house. We're not making the same thing over and over and over again. We're making different things. I mean, I have all my printers running right now, and they constantly like that, basically 7 days a week for the past, almost a year. And it's always different stuff. And having you guys like realizing this is what we really need, and you guys being able to integrate that into the system has been absolutely wonderful. And so we're super happy with what we have here.
What's been kind of the high level impact on your business to be able to print parts that you can validate and that can replace aluminum parts? What's kind of a high level benefit to your company?
Getting time back. It's even with all the high-end machines that we do have here, our CNC machines, there's not enough time in the day for what our workload is. And even if it's something as simple as like, I have to go set up a CNC machine in order to run, that takes time. Where with the printers, I can sit there and say, I know that this is going to work. I can hit print, it'll run, and I know I'm going to get a good part off of it that I can fly. And it has greatly reduced things. And then also too is the R&D side of it. If I have a part that we're experimenting with, whether it's a part that is going to be finally out of printing, or if it's a part that's going to be made out of aluminum or another material later, being able to R&D that part, go out to an aircraft, fit check it before wasting time just trying to machine it. And that's the other really, really nice part about it. Messing with the different print resolutions or your print thicknesses, we can move it up to was a 0.2 millimeter, and we can fly through a part really quick. I can take that, I can walk out to an aircraft, I can fit check and go like, yeah, this is going to work just how we want, or no, this is not going to work how we want. We need to make this adjustment, go make my adjustments, and then put it into production. And especially with certain parts, if we're doing like parts that are going to be hanging on the outside, things like that, we tend to lean towards making more aluminum parts out of that. Or if it's a structural part, we'll make it out of aluminum right now. So that's been super helpful for us.
I know there are multiple types of fiber you could choose from. Which one do you typically use?
Carbon fiber only.
Carbon fiber. Okay.
Yep. We have found that the cost, if when you're actually physically looking at what the cost of those spools are, right? The cost difference looks like a lot because you may be talking, $20, $30, $40. The amount of time it takes me to change out a spool doesn't make sense. It just doesn't. I understand, talking to Chloe, we were talking about tooling, and I think you had mentioned the fact of, one of your customers uses Kevlar simply so when it wears, they could see a different color. Where we're not in a position that we need that. We need the strength, we need the rigidity. The carbon fiber has just performed better than anything else that we've used. For us, there's no reason to even try anything else because we know it's going to do what we need to do. We've had a couple talks with people about if we needed something that was a little more impact resistance, maybe using Kevlar, but as right now, we've never kind of bridged into that. We haven't had a need to. So it's been carbon fiber all day, and it is fantastic for what we're doing.
Can you maybe share a little bit about how you know how much carbon fiber to put in a part, and then what you're doing to verify that you have enough strength in your parts after they're printed?
Sure. It all comes from testing. The FAA has guidelines for testing parts. They say, based on what the G loads are. And we've kind of figured out in-house a formula that we know will either be able to meet or exceed that. I would say 95%, almost 100% of the time, we're way exceeding whatever it is they want from us. And so we've been able to say, like, okay, I know that if I have a part that's, if I have a part that's this flat, I know how much carbon fiber that I need to put into it in order to make it exceed what it is that we're trying to do with it. And that just comes from testing. We'll have, this part itself, when this came off the printer, we took it, we pull tested it, we know exactly what's going to happen out of it. It meets all the specifications that, not only that we set, but that we're exceeding all the FAA specifications for being able to test a part. And so it's a lot of just testing. It's a lot of testing, it's a lot of knowledge and a lot of documentation that we've been doing to get to that point. And it's the same thing with, parts that we have that are, flying, whether it's an ST seat or DE yard. Same thing, pull testing. We pull test. You got to pull test everything. You've got to do the impact testing. You got to do your G load testing. We've got parts that have gone out and have been certificate tested. We've got parts we've made that are, went through a full DO 160 and everything else. So we've had enough experience to know what's going to work for it now.
Thanks, that's great.
Appreciate the great conversation. I think we've covered most of the questions. And Charles or Chloe, do you see any remaining questions that we want to address before we summarize?
I know that there's one.
What's that?
Yeah, dealing with the FAA.
Do you have any magic formula?
That's a big one. We've been.
Do I have a formula?
Well, a magic.
Do I have a magic formula?
Yes. The FAA like you?
I can just, here's what I can tell you. I'll tell you our experience. We personally, as a company, have a fantastic relationship with the FAA, with our local FSDO, with all the reps that we deal with. One of the things that I tell people that kind of sets our company apart from everywhere else is when you get your aircraft from us, you are going to have more documentation for your aircraft than you possibly are ever going to use. We document everything. We're super detailed about what we do, everything from the individual parts that we put in it to your paints, to your weight and balance sheets. We give you everything. Doing that and having the FAA being up in our shop quite often has led it to, honestly, it's a level of trust that we have with the FAA. When we started doing the 3D printing and we had the FAA in here, one of the questions that one of our local FAA guys asked me is like, well, how are you signing this off? And I said, you've given us the guidance. You've already told us this is what you need from me. You need me to record this. You need me to test this. You need certificates for this. If you need flame certs, you need, you have a formula for us. Here is all that information for you. Is that what you want? And the guys will come back to us and they said, yeah, you guys are covering all of your bases. You're doing everything that you were supposed to be doing. And what we've realized is that there's no difference between 3D printing a part and me machining a part out of aluminum. It's the same process. If I have to be able to prove that with a bracket that I make out of aluminum, I have to give them all the certs. I have to give them my inspection reports. I have to have all my material certificates. I have to have all this information. And I hate to say this, but one of the things that we realized going through this whole process was how much of this stuff people actually don't do, or is tribal knowledge. And you say, well, it's made out of 6061. We're not going to test it because we know it's going to work. But realistically, that's not actually the right way of doing it. If you're making a part, you need to be testing your parts. And so it's been eye-opening for us because obviously, being in aviation in this industry long enough, we all know that people just automatically assume these things. Well, now that you actually have to prove it, and then I have the FAA up in here, I have to prove it. Here's all my information for you per your guidelines. And once you show them that, everybody's been like, oh my God, yeah, this is great. And I know that the FAA themselves are, they're working on more guidance and more white papers to try to clarify a lot of this for us. But as of right now, we're doing everything that we're supposed to be doing per your guidance, and they've actually been really, really receptive to it. One of the things I also tell people, because I've talked to a lot of other companies about this, is I can give you all the information I have. That doesn't mean that you're going to be able to get any of it signed off or have the FAA approve any of what you do, because as people who've been in the industry long enough, you have certain shops that may not have a very good reputation, or may have maybe known for having things that fail or come back, aircraft that come back for issues. The FAA is probably not going to look at you. They're probably going to scrutinize what you're doing maybe a little bit more than what they would us, simply because of the fact that you have a reputation with that. We have a very good reputation. We do that for a reason.
Great, that's really helpful. Matthew, I think we're going to just share some final slides to sum up as to what we've covered today.
Sure.
So I think, Charles?
I think one of the major challenges that we see here, and not only with Hangar One, but just in general with a lot of our customers, is that when you're making custom low volume parts that are like difficult to CNC machine, or that take, you're making one or two of them, right? You're gonna have to go through this whole setup process just to get a part made. You have to set up inspection, do all this stuff. After all that, you get one or two parts. Sometimes that's just really difficult to justify. And I think having a 3D printer in-house that is able to produce those parts, give them strength, and also give you that inspection just makes it such a lower, just a lower barrier of entry to get something made. And I think I can see just exactly why you would do something like that for R&D. That makes total sense. But as you said, Matt, as soon as you got the machine in, the application space just expands, right? You're like, oh wow, I see that you can do that. Hey, wait, how did you make that? And then suddenly everybody's flocking you for parts, right? Like that's what we tend to see, and I think it's reaffirming for me, at least, knowing that our product does have so many use cases. As far as the solution that we're presenting, I guess I touched on this a little bit earlier. Additive manufacturing of these parts is significantly faster and simpler than a lot of these processes. Like, maybe not necessarily on a time to part basis, right? Like if you're looking at the time to machine one part, like if you're just looking at the cutting time, like, yeah, you could cut it in an hour, but what are you going to have to do to get that stock material in? What are you going to have to do to set up your machine, to get the machinist here? What are you going to have to do to get the QA done? There's like a bunch of manual finishing processes. Yeah, if you have multiple steps, like it's just going to be a bit of a nightmare. Yeah, making tooling for work holding, like for some of these more complex parts, that all adds up. So when you're able to just do that all at once, it's Matt, what's up? You got something to say?
Yeah, actually I do. The tooling for machining. Now this is not on our X7. This is actually on a Mark II that we have. We make soft jaws on that for our 5-axis all day long. We are making some seriously complex structural parts, and we're just making so many different ones. Being able to have soft jaws that I can print, I can slap my machine, it saves me so much time. Because anybody who's done a lot of machining knows that sometimes your fixturing is the hardest part of a whole job. So I just want to say that for it.
Yeah, totally. And it makes a lot of sense, right? And you start with the Mark II, and then you expand out into the X7 so that you have more capabilities, more materials to work with. But even still, that Mark II has, it's got its next career, right? Like, it goes from R&D to tooling, and that's a beautiful story, right? Like, it's growing in its career path as well. Cool. And I'm going to defer this slide.
Chloe, you want to take this one?
Summarize this one?
Yeah, happy to. So I think this is just kind of reinforcing what Matt said. 3D printed parts that go on aircraft are no different than machined or extruded parts. At the end of the day, what you're doing to certify a part and to put it on an aircraft is you're identifying all of the requirements that part has, whether that be a load requirement or an environmental requirement, a vibration requirement, a flammability requirement, and you're finding a way to show the FAA that you've met that requirement. That can be a test, that can be an analysis, that can be past data that you have or allowables data. And you're just going through and you're doing all those tests and you're submitting all that documentation. And I think when we talk about additives, sometimes we can get caught up in the fact that it's a new process and that we don't have a lot of previous history with it. But all that the FAA is looking for you to do is to identify those requirements and show how they're met by your 3D printed part. And sometimes it's a little bit more testing than if you're making the part out of aluminum, because we have so much historical data about aluminum. But it's still the same process. And if you're familiar with certification, you're not going to be learning anything really new beyond maybe some new ways to do testing. And we're going to support you through that process as much as we can. But at the end of the day, it's the same process.
That just leads us into an automated inspection process. So replacing manual processes with one that works as the parts are printing, and you print the part and you automatically get the analysis. You get a report that you can download, or you, actually with our new Eiger API for scan reports, you can automatically retrieve that and put that in a QMM system or wherever you need that. And the data's in the cloud, as Matthew mentioned. You might have printed and scanned a part 2 months ago, but you can reanalyze that same data cloud now using the new features that we deliver to Blacksmith. So it's a very powerful system that takes time out of it, adds reliability and traceability.
We had a few requests, Matt, for you to give some parts a close-up. Is that something that you'd be willing to do?
Yeah, absolutely. Let's see what we got. This is on a part that is, oh, there we go. This is on a part that's going to be flying, actually one's going to be flying out next week, and a sister ship that's going to be here days. So customer wanted another cup holder. These law enforcement guys love their cup holders. It's a weird thing. So this is actually 3D printed part. This has been totally finished. We sand down, we fill it, and we paint it. Even got ourselves, if you can see, a nice little drain hole in the bottom there in case they do spill, which these guys do. So we've got that. This was the part that was in Blacksmith that we were doing. It's a bracket. This one actually has heat set inserts that are in it right now. It's going to be used to hold a modem in plate. Sorry, a modem in place. And this, I don't have the finished one here, but I'll at least show you as far as tooling goes. So we made this as actually a manifold that goes inside of one of our 5-axis machines, and it has coolant nozzles that go all the way down it. And this is for high pressure at 2,500 PSI with our coolant. And actually we just use it for cleaning our machine. It actually works great. And there's another gentleman here in San Diego who I actually sold like 3 of these to the other day for his machine. And then what else we got? This was an R&D piece that we have for this. Because of where this actually goes, this has to be made out of metal, and we have lots of metal ones. But this actually goes on a tail boom of one of the helicopters. It actually holds a small lipstick camera so that when they're taking off or landing, they can see the skids of the airframe or of the aircraft. And so we've 3D printed. We have a couple different versions that we've 3D printed, and really what it is just to check our radius that it matches up to the airframe and the tail boom correctly.
There's a question as to whether you print any load-bearing parts.
We do print load-bearing parts. Those ones go through DER or STC and for their final approvals.
I see a question here about thermal expansion. So yeah, I guess if you're measuring in the printer versus after build, well, I'll preface this by saying that we print in a non-heated chamber. So it is, although it may be a little warm because there's essentially it's like a 100-watt light bulb, it outputting a little bit of heat in there. It's not particularly warm. So yeah, have you had any experience with like measuring a part before and after? I think you mentioned that a little earlier.
Yeah, we've measured it before and after, because that's one thing we were worried about. The shop that we have here is for the most part climate controlled, so we keep it at a certain temperature. Yeah, it is warmer inside of that chamber when you have it. However, based on the tolerances that we need to keep, we haven't had any issues as far as that goes. There is a little bit of a difference if you really want to get down to the nitty gritty, but we are not inspecting that many decimal places down.
And just a heads up, we do have our Metal X printer and our FX20 printers that do have heated chambers, but the X7 industrial printer that we're talking about here with Blacksmith is not a heated chamber.
Let's see, another question here. Have you printed any molds? I guess I've seen molds for urethane. Yeah, what have you done with molding?
We printed a couple molds. We have a full carbon fiber shop here too, across the street, and we printed a couple molds for those guys so they could do layups on. And that was a little bit of an interesting experience because obviously when you're doing it, we're trying to take into account thickness of the material those guys are going to be using and their processes. And one of the things that we were trying to figure out was how to keep everything from sticking to the onyx. And so that took a little bit of some trial and error, to say the least, to find the right coating to put on the onyx afterwards so it would release correctly, versus, if we were making one out of aluminum or one out of foam or anything like that. So, but once we figured it out, piece of cake. Now it's easy. So, and honestly, all it is we'll give it a really good sand and we just clear coat it and buff the clear coat and put some mold release in, and it pops out real nice. And we've got our settings of how much we have to offset when we print to make it to give them dimensionally accurate parts.
Yeah, maybe just to sort of carry on with the theme of sanding, I know you've done some great stuff with finishing and painting. Do you find that the finishing and painting of printed parts is easy, or is that a challenge for you?
I don't think it's a problem. But then again, I also have a really, really good painter on staff. And him and I have talked about it, and he doesn't think it's too big of an issue for him. I mean, he's really good at what he does. Although I've had, I had a new hire that I had, go through the process, and they're like, "Oh my God, this really sucks." And I'm like, "Well, you just got to get the right technique to make it work properly." And so once you've got that, it's not even a big deal. Was it last weekend? I was sitting here and was the only one in the shop, and I was doing some parts myself, and filling, using the filler primer and painting it, and I don't honestly think it's too big an issue.
That's great to hear.
I was just going to mention while we got you here that if you have any of those molds that are unfinished, or if you want to send over a mold file, that would be pretty interesting also to send through that post-processing and get it smoothed out. I wonder if that would do what you wanted it to, or if it would change the surface characteristics.
Yeah, I mean, I could try to find something.
Cool.
But the part that I was actually going to send over was going to be this, because of just the size of it, when it sits on our show and tell table, like having something that has like a super nice finish would be really, really nice for our customers to see. That's why they love seeing like the finished ones like this. And so we have a couple of these that sit out there as well.
Awesome.
People at the trade shows, like the upcoming Rapid TCT one, love to see the parts, and they are amazed by the ones that come right off the printer that have a wonderful finish, but then they look at the ones that have been painted or sanded and so on, or chrome plated, and they're just further amazed at what's possible with composite parts. So
yeah, I think that we'll have some parts that Matt gave us and painted for us on the table at Rapid. If anybody stops by and says hello to Markforged, it's a great opportunity to see those parts.
Great. Thank you everyone for joining us today. Have a great day.